Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, how are you feeling today? I hope you are all in good health. In this session, you will be with me. I am Ni Adewati binti Ni Arif from SMK Taman Jasmine 2. Today, we will learn about light and optics. Have you taken a look at your face in the mirror today? Does your face look different? No? But what is the difference? Yes, the right side of your face looks like your left side. In this topic, we are going to learn about reflection of light. Refraction of light, dispersion of light, and scattering of light.
Light is a wave. If you throw a rock in a puddle, the water will ripple because the disturbance moves radially outward from where it began. The water molecules merely move up and down. A wave includes 4 properties: amplitude, the size of displacement from the disturbance; wavelength, the distance from one disturbance to the next measured in meters; frequency, the number of waves that pass a stationary point measured in cycles per second or hertz; and wave speed, the product of wavelength and frequency measured in meters per second. As a wave, light can expand and radiate in all directions, interfere with other waves, bend around corners, carry energy and momentum, and interact with matter. Not only is light a wave, it is an electromagnetic wave. As such, light can travel without a medium. The rock thrown into the puddle created a wave that traveled through the water, which was its medium. Electromagnetic waves are essentially their own medium. A changing electric field makes a magnetic field and vice versa. Since electric field waves and magnetic field waves make each other propagate, they do not need another medium to exist. Different wavelengths of light interact differently with matter. The electromagnetic spectrum comprises of the radio waves, microwaves, infrared waves, visible light waves, ultraviolet waves, X-rays, and gamma rays, from the largest to the smallest waves, respectively. All these electromagnetic waves travel at the speed of light, but they interact differently with matter. All objects produce light. Electromagnetic waves. Objects often emit electromagnetic radiation in the infrared spectrum, preventing you from seeing it. If you have an infrared camera, you will see that different colors correspond to the different temperatures of the objects. Objects create shorter wavelengths as they grow hotter. The objects could eventually look red or white as the shorter wavelength is produced, and this is made visible to the human eye. Ultraviolet light can be produced at even higher temperatures. Some animals can see wavelengths that humans cannot. For example, the ultraviolet light, UV light.
By the end of today's lesson, you should be able to state the characteristics of image formed by a plane mirror and solve problems in daily life with the application of reflection of light. Generalize the relationship between the angle of incidence and the angle of refraction. When light travels from a medium of low density to a medium of high density during refraction of light. Justify the application of refraction of light in daily life. Communicate about the dispersion of light and explain with an example the dispersion of light in daily life. Explain with an example scattering of light in daily life. Our first subtopic is the reflection of light. Look at the boy and the image of the boy in a plane mirror. What can you see? Let's write down the list of the characteristics of the image formed on a plane mirror. First, the image formed on the plane mirror is upright. You can see that the image of the candle is upright. This is just the same as the object. Second, the size of the object is the same as the size of the image. Hence, the distance of the object is equal to the distance of the image too. Third, the image is laterally inverted. For example, if a person is reflected in a plane mirror, the image of his right hand appears to be the left hand of the image. It is virtual. Now, let's learn about the law of reflection of light. Please look at the diagram here. The incident ray, the reflected ray, and the normal line all lie on the same plane. As we can see, the angle of incident, I, is equal to the angle of reflection, R. Now, let's look at the application of reflection in our daily life. Look at the picture here. Do you know why the word ambulance is written in a laterally inverted manner? Yes, you are correct. The word is written in a laterally inverted manner on the front of the ambulance to enable motorists in front of the ambulance to easily read it on their rear view mirrors. This is very important, especially during emergencies, when ambulances are rushing to save lives. It is the same as why the policeman wears a reflective safety uniform at night. This is so that he can easily be seen at night.
The first form of a mirror was invented in ancient times. It was actually a small pool of water filled in a dark-colored container. Think of this concept as looking into a fountain as you walk by and seeing your reflection in the water. After the water mirror was created and used in everyday life, people started making polished volcanic glass mirrors around 6000 before century. The first polished copper mirrors appeared in Mesopotamia. Polished copper is exactly what it sounds like. It is a polished, shining piece of metal that will let you see your reflection in. The mirror that you see today is not a new invention. It was originally invented in Germany by a chemist, Justus von Liebig, in 1835. He discovered that if you apply a thin layer of metallic silver to a piece of clear glass, you can create a reflective surface, which is the mirror. Believe it or not, mirrors can reflect sound waves. They are known as acoustic mirrors and were used during World War II in Britain for detecting sound waves of the enemy. Before the development of radar, mirrors were used in the Second World War to detect sounds coming from enemy's aircraft. Reflections are usually caused by shiny things, such as mirrors, that show a reversed image of whatever is placed in front of them. The image seems to be as far behind the mirror as the object is in front of it. Mirrors are not the only things that make reflections. However, most objects reflect some of the light that falls on them. In daytime, we see familiar objects like grass, trees, and the sky only because they reflect light from the sun into our eyes. A convex mirror curves or bends outward and makes an object look smaller and further away than it actually is. It makes light rays seem to come from a point behind the mirror, further from our eyes. Things look smaller, but convex mirrors are helpful because they can show a wider picture or field of view. A concave mirror curves or bends inwards and makes an object look bigger and nearer than it actually is. It works by making light rays seem to come from a point in front of the mirror, which is closer to our eyes. Concave mirrors are important in such things as bicycle reflectors and reflecting telescopes. Drivers use mirrors to see traffic coming up behind them. It is important for drivers to see as much of the road behind as they can. So wing mirrors and rear view mirrors are convex. A disadvantage is that they make vehicles on the road behind look smaller and further away than they would be in a flat mirror of the same size. Drivers must remember that the vehicles are nearer than they appear. A creepy fact about mirrors is that research has found that mirrors can cause hallucinations. Many people have declared that if you sit in a darkened room about 3 feet away from a mirror and stare at your reflection for about 10 minutes, you could start to hallucinate. This is caused from the small distortion developing within your reflection. Other people have declared seeing other human faces appear, as well as animal faces.
Okay students, now let's learn about the refraction of light. Have you ever wondered why a pencil looks bent in a glass of water? This is called the refraction of light. What does refraction of light mean? The change in the direction of movement of light when light travels through two mediums of different densities. Now, I will show you the relationship between the angle of incidence, I, and the angle of refraction, R. Let's look at the diagram. In this diagram, light travels from water, which is a medium that is more dense, to air, which is a medium that is less dense. The light ray is refracted away from the normal line when the incidence ray moves from a more dense medium to a less dense medium. On the other hand, let's take a look at what happens when light travels from air, which is less dense, to water, which is more dense. The light ray is refracted towards the normal line when the incident ray moves from a less dense medium to a more dense medium. We now know that a light ray traveling from air to water will be refracted, and so too will light from water to air. This means that if a fisherman is trying to spear a fish in the water, he must make adjustments to the angle of throw. This is because the fish appears to be at a shallow depth, but it is actually a lot deeper. Now, let's learn about light dispersion. Boys and girls, have you ever seen a rainbow? How is a rainbow formed? Yes, it's true. The rainbow occurs when sunlight enters rain droplets in the sky. When this happens, the white light will be refracted and dispersed into 7 different colors to form a rainbow. Rainbows are really beautiful, are they not? Can rainbows be produced at home? Of course they can. Let me show you how this can be done. Place a piece of white paper on the ground under the sunlight. Put the prism on or above the paper. Rotate and move the prism around until you see the colors of a rainbow on the paper. Now, let's learn more about the scattering of light. Why does the sky appear blue at midday and reddish in the evening? These two phenomena are caused by scattering of light. The scattering of light occurs when light is reflected in all directions by clouds or particles in the air. During midday, blue light is scattered the most in all directions by the tiny particles in the atmosphere. Therefore, the sky looks blue during midday. Meanwhile, during sunset, the sun is at the horizon. Red and orange light are less scattered and will go through the atmosphere to reach your eyes. Other colored lights, such as blue light, are scattered away. Therefore, the sky looks reddish during sunset. Let's try the mastery exercises below. Number 1. The image that is formed on a plane mirror is A. A virtual image, or B. A real image. Correct. The answer is A. A virtual image. Number 2. When light rays pass from air to water, it is refracted. A. Nearer to, B. Away from, or C. Towards the normal line. Yes, you are correct. The answer is C. Towards. Let's continue with question number 3. Dispersion of light causes the formation of A. Prism, B. Rainbow, or C. Reflection. Correct. The answer is B. Rainbow. Good job, boys and girls. Now, we have reached the last question. Which color of light is scattered the most during midday? A. Blue, B. Red, C. Orange, or D. Yellow. You are absolutely correct. The answer is A. Blue. Boys and girls, after today's lesson, you are able to state the characteristics of image form by a plane mirror and solve problems in daily life with the application of refraction of light. Generalize the relationship between the angle of incidence, I, and the angle of refraction, R, when light travels from a medium of low density to a medium of high density during refraction of light, and justify the applications of refraction of light in daily life. Communicate about the dispersion of light and explain with an example the dispersion of light in daily life. Explain with an example scattering of light in daily life. We have come to the end of our lesson, boys and girls. I hope you enjoyed the session. Goodbye.